This is the center of our galaxy, the Milky Way, captured in never-before-seen detail. And those stars, that dense, bright clump, most likely goners. They're breakfast, lunch, and dinner for the supermassive black hole that lurks at the heart of our own Milky Way.
We can't actually see a black hole because by definition, no light comes out from it. What we can see, though, is we can see the material around the black hole. As the material spirals into the black hole, it's kind of like water going down the drain in a sink. We could have a very big rear bearing.
With support from the National Science Foundation, University of Florida astronomer Steve Eikenberry and colleagues are building and operating a new class of infrared telescope instruments designed to peel back the layers of mystery shrouding black holes, like how they form.
We are really kind of stumped, and that is one of the great mysteries in astrophysics. How do you make such a supermassive black hole, and why are they so common in galaxies? Almost every major galaxy has one.
He says their structure is not complicated.
A black hole is actually a pretty simple thing when it comes right down to it. It's any object that has gravity so strong that not even light can escape from its pull.
But the finer points, like how they interact with their host galaxies, are anything but simple. These are some of the questions Eikenberry is exploring using a new instrument built for the Gemini South Telescope in Chile.
Is it born in the center of this galaxy as a supermassive black hole somehow? Or are they born small and somehow through merger or through accretion, basically consuming material around them? Do they grow to become big later on?
Eikenberry also studies smaller so-called stellar mass black holes. A typical galaxy is chock full of them. They're born when a big star, similar to one of these in the Tarantula Nebula, dies in a huge explosion called a supernova.
So we're really sort of studying not so much the black hole, but the process that gets you to the point of forming a black hole.
Eikenberry says that big or small, black holes likely function much the same, and he's hoping to shed some light on how they work. It would seem black holes have really sucked him in. For Science Nation, I'm Miles O'Brien.